Hello everybody, I am Subbu Ramanathan from grade 11 and today I will be showing you my model Smart Traffic Control System. So basically my model has two main subparts, that is the transmitter and receiver. So I'll tell you what a transmitter is and a receiver is. So we know the radios are radios, right? The radios get the data from the satellite. So here the satellite is the transmitter and the radio is the receiver. The radio receives the data from the satellite. So here the receiver receives the data from the transmitter, and in basic I'll tell you what my model does. So this one is the 3D representation model. For this model, I'm using a 4-junction road, and here we'll assume that the north signal. So for now I'm taking an example of a fire truck. So once the fire truck is coming to the north direction, this north signal must be green. That's how it could pass freely without any congestion. So the ambulance driver, before a half kilometer or 1 kilometer, would press the transmitter button. He will choose which direction he is coming in and what vehicle is he traveling in. And once after he presses the north button and ambulance vehicle, this signal turns to green, that is the north signal. If he's coming from south, he can choose the other direction. So it depends on direction. And here the other vehicles will be passing through a normal cycle, and that would be stopped and converted into a, like, how to say, this one becomes green and others become red. It will change the direction of green to which one the emergency vehicle is coming in. And now I'll explain you what the parts are used in transmitter and receiver. So as you can see here, I have the main part, that one is the LoRa module. Here the LoRa module means the full form of LoRa is long range. It transmits data around a radius of 1 kilometer actually, but they have told 2 kilometers, but it's not actually working for 2 kilometers as we have checked. And this one comes with an antenna that used to transfer data, and the common configuration of this one is SX1278, and the frequency of this one is 433 megahertz. And the next one is the rotary encoder. The rotary encoder is used to choose the vehicle type. This one is the same as the fan regulator that we use in our houses. 1 for low speed, 2 for medium, 3 for high but not so high, and 4 for high speed. Here the same is used. 1 for ambulance, 2 for fire engine, 3 for police vehicle, 4 for VVIP vehicle. And these 4 vehicles are chosen based on priority basis. And here we have 4 switches and 1 send button. This 4 switches, north, south, east and west, is used to choose the direction in which the emergency vehicle is coming in. And this one is the send button. This is used to confirm all the data that is being processed through the rotary encoder and direction. And this one is the final touch, that is the send button. So we'll go to the receiver now, and I want to make sure that this transmitter and receiver is working wirelessly. And here we have the Arduino UNO board and the same LoRa module with the same configuration. And I have 4 signals here: north signal, south signal, east signal and west signal. And this one is the LCD model, that is the liquid crystal display with I2C. As you can see, the I2C present here. And this one also comes with an antenna, so the data are being transmitted at a rate of 433 megahertz. So I'll show you the serial monitor of this transmitter, so you can see that what data this is transmitter sent. So I'm taking a laptop for this one. As you can see that I've connected my laptop to the Arduino IDE board. And here it will show I'm opening the serial monitor, and it shows LoRa OK, which means that our transmitter model is working. So I'm adjusting the rotary encoder here. So yeah, fire truck, ambulance, police vehicle, VVIP vehicle, and it will choose, and the driver can choose which vehicle is he's traveling in. And for example, I'm choosing ambulance, and I'm choosing north direction, south, east or west. So for example, I'm considering a case where an ambulance is passing through the north direction. So which means that the north signal must be green and the rest all the three signals must be red. So I'm choosing the vehicle type. So I've chosen ambulance, I'm choosing north direction, and I've confirmed the data that is provided. If I want to more precisely understand which vehicle, I can also use an LCD display here, but I don't want to make it like so congested, so I'm not using this one. I'm using serial monitor to understand this one, and I'm pressing the send button. So once I press the send button, the data is sent and it will be waiting in the LoRa here. So once I powered it, the message will be received as received. So I'm connecting this one. You can see that the vehicle direction. So yeah, it shows that ambulance and north direction. Because why I've used this liquid crystal display is because the normal cycle functions as it does, and suddenly if there is a change in signals, the people like other travelers won't understand why. That's why I've used the LCD display, and I can also add a buzzer in this one, so that it makes like a sound to understand what it's doing. And you can also ask that why I've made this LoRa module. Even I can use GSM, GPS, or any other Wi-Fi accessible data, but I much prefer one like without using data because it's not much reliable. If you are being in a remote area where you can't access any data or any Wi-Fi, you can use this one. This one is very reliable, very cost efficient, and it's 100% working. I checked it. I checked it basically in a school demonstration. I've done in many school experiments and projects. I've done this model, and I've also made a booklet for this one. You can also scan this to use this booklet. You can scan this QR code, and here is the booklet. You can see the overview of this one, and I've also predicted the future of this model. That's this one. That's the ambulance driver's comment regarding our model. That's the ambulance driver telling that this model has actually worked and it saved a life. So that's a model. Thank you.